So I want to introduce to you today David Lonergan, Micheal, Mawe and Tom Crowder, who will be talking about the Leakage Reduction Program. And I'm going to actually hand over to David now, who will do introductions for the speakers, a bit more detailed, and we'll then get underway with the presentation. So thank you and see you in a little bit.
Thanks, Sheila. Hello, everyone. I'm delighted to be presenting this lunchtime lecture, and thank you to Engineers Ireland for the invitation to present. My name is David Lonergan. I work in the Asset Management Directorate in Uisce Éireann, where I have the role of National Leakage Manager, and I've been working in that role now since 2018. Joining me today is Tom Crowder. Tom is a director at Crowder Consulting, and Crowder Consulting were responsible for delivering the net-based system, which is the leakage management system we'll be talking about today. And finally, I'm joined by Micheal Mawe. Micheal Mawe is the leakage management system lead and has been leading that system and the team responsible for it since 2018 as well. So between the three of us, we hope to deliver a good lecture and hopefully give you some insights into how we're managing our program. Okay, next slide, please. Okay, so the agenda is as follows. I'm going to give a brief update on Uisce Éireann's leakage program, but really I'm going to focus on, I suppose, the complexity of the program and how we use data-driven decision-making to drive our decisions and allow us to invest in the most efficient and effective way. I'll talk a little bit about the leakage management system at a very high level in terms of how we use it for strategic and tactical decision-making, and also in terms of our output reporting. Tom will join me after that, where he will discuss the journey that Crowder Consulting, working with Uisce Éireann and the local authorities, took in 2018 in developing the leakage management system. I think when you see the complexity and the level of work that was involved in getting to where it is now, it's quite impressive. And then finally, Micheal will take over. And Micheal is actually going to show us the system itself. He's going to show us a couple of demonstrations of how we use it on a daily basis to manage a very large and complex leakage program. Okay, next slide, please. Okay, just talking about what is leakage. So leakage is the escape of water from pipes or fittings and also service reservoirs. Now, it sounds quite simplistic when put that way, but really what I'd like to show today is that it sounds very simple, but when you're managing leakage at a national level, it is a highly complex program. And really what I'd like people to take away today is just show how we have leveraged big data and very sophisticated systems to support our capital and operational leakage programs. Next slide, please. I know I've showed this slide at a couple of previous sessions, and really what I'm trying to bring across here is just how complex the water network and water system is in Ireland. So we're producing around 1,700 megalitres of water a day. We have around 63,000 kilometres of water pipe within that, and that's broken down into trunk mains, distribution mains, and supply pipes. We estimate there's around 12.5 million joints on that system, each of which could have a small, a large, or a weeping leak. We're running at 37% leakage now. We'll talk about that a little bit later on. 788 water treatment plants, which is huge in comparison to our UK, maybe European neighbours. We currently have around 1.1 million water meters between customer, DI, DMA meters. So a lot of information coming into us. And of that, 4,500 bulk meters, which measure our DMA network. And finally, we're serving a population of 3.8 million people. Okay, next slide, please. So what I want to show here is just very briefly just the journey that Uisce Éireann has gone through in terms of the setting up the leakage program. So in 2018, the National Leakage Management Team was established in the Asset Management Directorate. And I suppose the big milestone within that first year was getting local authority and capital staff operating across the country in terms of a joined up national leakage program. Moving into 2019, and really what the focus is today is about, in 2018, we're developing the leakage management system, and that's what Tom will talk on today. But in 2019, we went live with the system, and that really kind of set the scene for allowing us to strategically manage the national leakage program. Jumping into 2021, the next big milestone really from my perspective is that we published a leakage strategy, and that kind of set the ambition for Uisce Éireann in terms of where do we want to go in terms of leakage, what were our ambitious targets we were going to achieve, and that allowed us to formulate the various scenarios to get there, including the investment that would be required between now and the next number of capital investment periods to achieve those numbers. In 2022, we started deployment of innovation. In terms of, I suppose, the big ticket items are a large rollout of advanced pressure management systems. And also that's when we started deploying acoustic loggers at a large scale. And really that's continued on. And then finally, we have had really good engagement with our regulator in terms of leakage, which is the CRU. And that's in terms of understanding our water balance and having full transparency in that. And really, again, in terms of today's discussion, the leakage management system is key to that discussion and that relationship with our regulator. Okay, next slide, please. Okay. Okay, so starting to focus in a little bit on the leakage management system. When I'm often asked about what is the system, what does it do, I'd like to break it down into this kind of high level component. And again, look, Tom and Micheal will get into kind of the detail, but really for me at a high level, what does it do? Well, we have 6 enterprise systems within Uisce Éireann that are consuming data. We have a geographic information system that shows us where our pipes are, where our DMA network is. We have a work asset management system that tells us, you know, if we issue out work, who goes, like, where do they go? What is a problem cause and remedy, and where do they find it? Okay, so if you think about, if I issue a release for find and fix, that type of work is recorded there. Our signals are signals coming in from our network telemetry. So in this instance, I mean our water network telemetry. So what's coming out of our plants, what's going into our DMA network. We have our billing information in terms of our domestic and non-domestic customers. So what are our customers consuming in terms of water? And finally, we have our customer information. Are they domestic? Are they non-domestic? That all feeds into the leakage management system. So I tend to term the leakage management system as a business intelligence system. It understands these data. It puts it together in an intelligent way. And what it does, it allows us then to understand what's going on in terms of leakage. And really, I look at the 3 big outputs from this in terms of work planning. So it allows us to plan work at a large scale. And I'll touch on that scale in a few minutes. It allows us then to understand what were the outputs and what were the outcomes. So, okay, we issued work out, like what was the outcome of that work and what was the output of that work and the outcome. So outputs are really in terms of what did we achieve locally, and outcomes are really, well, how are we doing at a national level or a local authority level in terms of our leakage levels. And last component there is our water balance. So what are the big components of our water balance? So the leakage management system is the master system for telling us each component of that. How much water are we producing? How much water are we consuming? How much of that is measured? How much of that is unmeasured? And then breaking down subsequently. And I think Micheal will give you a good flavor of that later on. Okay, next slide, please. Just a little bit more detail on the first one, the work planning. So in terms of planning, the leakage management system is the foundation of all the planning, work planning and work issuing we issue out from an asset planning perspective. And in terms of leakage, there are these kind of 5 big boxes. So one is find and fix. So we have crews who find leaks and they fix them. And I always break that down into 2 pillars. One is our capital program. And our capital program's job is to go into an area and bring leakage down to a much lower level than it historically has been at. So they're really getting us to bring the leakage level down. In parallel to that, we also have operational staff who are more reactive. but their role is to maintain the level of leakage everywhere else that our capital programs aren't working. So you must have both of those pillars working in parallel for a successful leakage program. Underneath that, we have our pressure management program, and one of our clear ambitions in Uisce Éireann is to deliver a national CAM network. And again, the LMS is at the core of that. We have our first fix program, which looks at leak repairs on the customer side of the property, which has been quite successful to date. We have our water main rehabilitation program, whereby we replace water pipe assets at the end of service life to reduce service interruptions to our customers. And finally, we have our metering program. So we, as I said, we've 1.1 million meters on our program. How do we plan in a very strategic way and issue a work on that metering? And the LMS then allows us to look at how that work has gone. Did we achieve what we set out to do, and measure those outputs? So again, it's a fully systemized end-to-end process. Next slide, please. Okay, so how are we doing? I like to think we're doing pretty well to date. Starting off in 2018, we were at around 781 megalitres of water of leakage. In that 4-year period, we've brought that down to around 617 megalitres of water reduction, which is quite, which is fantastic savings over the period. We are seeing a little bit of a spike in the last quarter due to a lot of staff movement down to our Uisce Éireann transformation, but I suppose that's to be expected. Okay, so in terms of progress and what the leakage management system is bringing, I think it's clear to see that we are achieving what we're setting out to do. And again, the leakage management system is really at the core of that. Okay, next slide, please. Okay, I'm not going to go into all these numbers, but really what I'm trying to show here is the scale of the investment across those programs I mentioned previously, and the value, the volume of water we're saving from each of these. And a lot of these investments are gradually increasing during the subsequent years as we understand what our ability is on the capital delivery side, as we understand what level of activities we need to do to achieve the targets we've set out in our leakage strategy. And again, the reason I put this up here is the leakage management system is at the foundation of all these decisions, investment decision making. So it really does sit and allow us to strategically plan this level of investment and to achieve the outputs and outcomes that we expect when we set out our plans, maybe at the start of the year for that regulatory period. Okay, that's on 15 minutes. I think that was my time allotment, so I'm quite happy with that. Bang on. Right. I'm going to hand over to Tom Crowder, as I mentioned, is a director at Crowder Consulting. And look, I think what Tom is going to bring us through is the journey that Tom worked very closely with myself and Micheal and our team and our local authority partners at the time to understand, we had 31 different ways of doing things. We had a lot of different information, a lot of different areas, and he'll bring you through the journey in that 2018 period to get the system stood up. Okay, I'll hand over to you now, Tom.
That's great. Thank you very much, David. So just to really start off, we've broken down the key components of the leakage management system. And just to really get across it, it's necessary to set up the leakage management system to reflect the configuration of the entire water network to enable analysis to be automatically carried out each day. And the first building block is the baseline data, which is generated for all areas using the data loaded from the source systems that David illustrated earlier. And then the next key component is the configuration, and this is carried out for all areas, assets, customers, and data signals to establish the network relationships and assignments. So, and then the next building block is measured data, such as flows, pressures, and levels that are derived for assets and customers and areas using data loaded from source systems. And the final building block is the leakage analysis, which is automatically carried out each day to calculate non-revenue water leakage for the different area types based on a standard water balance approach. So we're just going to go into a bit more detail about these components. So next slide, please, Micheal. So the level of configuration analysis that can be carried out in the software is dependent on a client's, oh, sorry, if you could just go back, dependent on a client's network maturity and the availability of data in the source systems.
I'd say we need to.
It doesn't like that slide.
Yeah.
So we'll just skip that slide. But what that slide was showing was when we implemented NetBase in Irish Water, as David was explaining, we had to combine all the data for all of the different local authorities and then bring it all together and then into a standard way of looking at it to configure NetBase. And so this kind of process that's on the slide now just shows that the process that we went through to really get to the point of being able to do the software calculations automatically. So it's really trying to emphasize that the establishment of a water network to better manage leakage needs to go in hand with the implementation of the leakage management system. So I'm just going to go into each element of this process in a bit more detail. Next slide, please, Micheal. So a leakage reduction program often involves establishing new hydraulic areas such as DMAs and installing new assets such as meters and attaching new loggers to monitor flows and pressures. And so this network that's being set up on the ground needs to be obviously set up in the ground, but then it needs to be configured in the leakage management system. So if we could go to the next slide, please, Micheal. So as the new areas and the assets or existing areas and assets are set up on the ground, the software is configured in parallel. And so as we configure the software, it becomes then a digital representation of the network. So it includes the what we call the network hierarchy, which is all the area relationships, the network information, which includes all the information about meters and pressure reduction valves and loggers, the network trace, which includes all the boundaries and the connectivity of a network, and the network assignments, which includes the customers and pipes, and then the network data, which includes the flows and the pressures and the levels. The next slide, please. Once the configuration is done, then various analysis routines can run within the software to automatically generate key baseline information about the water network. So this information is used to define the areas and to be able to report upon the areas. It includes things like the length of the pipe mains, the counts of properties. It includes the consumptions, the night use, and it also includes all of the measured data, so the flows and the area pressures. So next slide, please. So following these kind of routines running, the non-revenue water and leakage calculations are then automatically carried out every day in the leakage management software, bringing all of the data together into a standard water balance. So this is one of the final results of all the analysis, and this enables David and Micheal's team to have that information at their fingertips. So all the water balance calculations and the kind of night flow calculations that they use for reporting and targeting. Next slide, please. Further analytics are carried out in the leakage management system software, which builds on the core data to better manage the network operations and active leakage control. So this illustrates some of the data they have in terms of alarms on the network or network events that are happening. So it enables to better manage them, as well as better manage their resources for targeting leakage control. I think that's that's me done. So next up is Micheal Mawe, and he's going to provide a demonstration of the system.
Thank you very much, Tom. Yeah. Hopefully the performance of the slides will keep up with us. So to those not involved in the water sector, on the face of it, managing leakage may sound like a simplistic task, but as you've heard, there's a lot of work behind it. One of the fundamental questions behind leakage is how do you measure it? Unfortunately, you can't measure leakage directly. To measure leakage, we must measure all of the water entering the network, which is your system input or your distribution input. And then as accurately as possible, we account for all of the places that water is delivered to. We then assume that the balance of whatever is unaccounted for must be leakage. Of course, it's not sufficient for us to do this at a company level. We must also do this at a local level, narrowing down the locations of our leakage. For this, we have over 4,500 DMAs across the country where we calculate leakage each day. And this is where a simple calculation starts growing in scale. The leakage management system is how we pull the data together from across the company into one place for cross-referencing and an overall view of our network. NetBase is the core at the center of this. Different aspects of our network are recorded across 5 different corporate systems. We have Maximo, which is a work and asset management system. We have CCNB and MDM, that's our customer care and billing system and our meter data management system. We have GIS, which is all of our spatial data. And then we have ODS. Looking at this slide, it's designed to look straightforward and manageable, but there is, of course, a huge amount of work behind each of these systems. For example, ODS. ODS is the source of all of our logger and telemetry data. It has 61 different source systems feeding it, including SCADA systems, data concentrators, and cloud-hosted services. ODS is tasked with providing the leakage management system with nearly 900,000 data points per day to support the calculation of leakage. This is the NetBase system, and I'm going to take you through a quick demonstration of the system itself. This screen is pre-recorded for the demo, so I apologize in advance if some of the timing becomes off because of performance. There are many areas and aspects of the functionality in NetBase, but only to be able to touch on a few today. From the hierarchy, users can quickly navigate through the entire network. On the other hand, if we know what we're looking for, we can take a quick shortcut using Find. For this demonstration, we're using Sussex Terrace DMA, as that is where we find the Engineers Ireland office in Clyde Road. Many details of the DMA are immediately to hand, such as a summary of our customers and our consumptions. Here we can see the property counts and recent usage for the DMA in total, along with a list of all the inlets and outlets of the DMA and where the DMA is in our system. In this case, we're in DCC Zone 6. We have been working with the local authorities to better understand our network and how to represent it in our IT systems. One of the key outcomes of this has been the creation of schematics for the entire network. These schematics will always be evolving as changes are made to the network itself. They are a useful tool to quickly understand our network. Still going. I think it is, yeah. The schematic also provides a quick view of key information, such as property counts, length of mains, average pressure, and the elevation of the highest properties. From the schematics, we can also update, link to other data, such as flow profiles for this meter. We can see here a typical diurnal flow pattern in blue. We can see the low pressure at night, or the low flows at night, and the higher pressure flows during the day, peaking in the morning. We also have in red the pressure data for the same meter. We can see that this is the inverse of the flow data, with higher pressure at night when the flow is at its lowest, and this increases during the day as draw from the customers increases. We can also link to a second meter here at the inlet meter, Sussex Terrace DMA. On this meter, we see a similar flow pattern in blue for the diurnal flow pattern, but this time we have a different data for the pressure. In this case, the pressure is lower, and we can see that the pressure data follows on the flow data. This is because we've installed flow modulated pressure management in this area to maximize and optimize the pressure. This is is an effective tool of reducing leakage, as we are preventing the pressure from rising at night. Pressure management also can reduce burst rates by providing better control of our network. NetBase also includes GIS functionality. By selecting the DMA and linking to the map, we can zoom straight to that section of the map, and we can view all the properties, pipelines, fittings, etc. Here we can see all the pipework, the hydrants and the valves in Sussex Terrace DMA. Another tool we have within the maps in NetBase is the thematic maps. Apologies here, the video is just catching up. I prepared a map here showing the changes in losses per connection per day in Cavan from the beginning of 2022 to now. On the right, we can see the legend and the scale. We're using per connection to normalize across our DMAs, so they're comparable one against the other. Over time, we can see where leakage is rising and falling. This lets where we can see leakage rising lets us target the resources effectively into areas that require interventions. We can also see leakage dropping in response to those interventions. Right, on to the next video. NetBase also gives us a quick view of our data, so we can see where all of our customers are across our network. For this, I'm just going to use Earl Street North as the DMA. We start with a list of all the properties, and then we link to selection on the DMA to narrow it down to just those in the DMA we're looking for. If I zoom across to the right, then we can see that of the 3,000 properties in the DMA, we can order them by largest to smallest to see which are the ones that are having the greatest impact in our DMA. We could pull up information from these, but as we do not want to share specific customer information, I'm not going to bring it up from here. Instead, I'm going to go back to the map, and I'm going to go back to the main view of Earl Street North DMA and zoom into the Irish Water offices. And instead, we're just going to use the Irish Water offices as a demonstration here. There are 2 meters for the Irish Water office. And when we open up details again here, we now see the details of the meter. We can see the meter number, and we can see the flow in liters per day, and we can see how that has trended over 2017 to now. And we can see that there's been a dramatic drop in the amount of consumption, especially from the start of 2020 onwards. If we jump to the second meter, again, we should be able to see the consumption profile there. And again, we're seeing a similar pattern with reduced consumption to the Irish Water offices, though it's not as dramatic as for the first meter. Other applications within NetBase include the water balance application, where we can see all our leakage numbers, the alarms and events application, and the campaigns application. The campaigns application, it has 2 key aspects for us. It records the benefits from water saving activities, and it provides a way for us to analyze the data that we have, where the repairs have happened, in order to see what lessons can be learned. Here we're seeing, Here we are seeing burst sectorization maps. Each of the squares is where repairs have happened. Each of the colors of the pipes are the different pipe materials across our network. This allows us to get a summary of what has happened, what activities have happened on the ground, and where we can see hotspots. We can see hotspots of whether they're service pipe bursts, whether they're mains bursts, and when we see them clustered together, it would inform us as to what activities might be most useful to us in being able to carry out repairs in the ground, or take preventative action to prevent those repairs from being required. These would include potentially rehab or again pressure management, etc. I can open up now to any questions.